Chapter 3 starts probability. And why do we want to study probability? You have any clue? And not so you can go to Las Vegas and lose all your money either. You're not going to beat the people that professionally run casinos for a business. That just doesn't happen. Well, we do want to study it, but it's like backwards. What do I mean by backwards? Well, in chapter 1 and 2, all that we've talked about so far is I said, oh, here's some data. Or in your group work, you say, here's some data. And I've asked you to say, well, okay, what can you tell me about the data? You look at the data, you put it into your calculator, put it into Excel, you draw a histogram, you figure out the mean, the mode, the median, the standard deviation, the variance, okay? You figure out the shape, whether it's skewed left, skewed right, whether it's symmetric, mountain shape, you do empirical, you're telling me a lot about the data. That's what you're doing, right? That's all that you're doing. And so you get this data and you say, I can tell you a lot about what we call the distribution of the data, right? How it looks, what's the middle, what's the most common, frequently occurring piece of data, how spread out it is. So that's what you've learned so far. That's what we've talked about. Okay, so let's flip that around a second. What would happen if you knew something about the distribution? And that's why we study probability, because there's some distributions we know something about. We don't even have to have any data. You know something about the distribution. So if you know something about the distribution, you might be able to better interpret the data. And in fact, almost the whole rest of the course we're going to spend here trying to figure out, well, we should know something about how the data should look, and let's look at the data and see if it makes sense. Let me give you an example. And that's why we study probability, because this is about understanding the distributions, and that's a lot of probability. I've got some dice here, and we're not going to play craps or anything like that, but I'm going to just... It is a six-sided fair dice. It's a really good example of probability. We use it all the time, right? Six-sided fair dice has got 6 sides on each side. It's got a dot, 2 dots, 3 dots, 4 dots, 5 dots, and 6 dots. Has everybody seen a six-sided die? Okay. So I don't have any data. But let's say, foolishly, I was going to sit down and collect some data on this die. And I'm determined to roll this die 6,000 times. I'm going to be here all night, rolling this goddamn die 6,000 times. And at the end, I'm going to say, geez, I wonder how many ones I'm going to get, and 2s, and 3s, and 4s, and 5s, and 6s. I'm going to roll it 6,000 times. I'm going to count up each time what I get. Well, you guys probably could save me a lot of time. If I roll it 6,000 times tonight, about how many 2s am I going to get?
1,000.
How much?
1,000.
Why?
Divided by 6. 6,000 divided by 6.
Well, how do you know that? That's magic. I was willing to spend all night rolling the die 6,000 times, and you were telling me the right answer. How did you know that? How did you know that? Somebody help me.
Because dice has 6 chances, 6 different options.
All right, 6 sides is fair. It's not weighted. It's not funny. I roll it 6,000 times. It's likely to end up.
It's a chance for all 6 sides.
Well, you guys are smart. You saved me a whole night of work. But that's absolutely correct, right? In other words, I would expect to get about 1,000 of each number, right? So you know something about how the data is supposed to come out. I didn't even have to spend all night rolling the die, collecting the data, and then say, well, let's draw a picture. You already have the picture in your head. You knew something about it. All right. Great. That's because you know something about probability. You know that it's more likely that this will land about equally likely on each side. That's called a uniform distribution, right? 1, 2, 3, 4, 5, 6. All right, let's say I'm really stupid and don't believe you. Okay, see, I know, no way you know that. There's no way you know that. Okay, I'm gonna sit here till the sun comes up, roll it 6,000 times. Turns out, somebody calls me up tomorrow morning and I say, I got 4,000 ones. What do you conclude?
You're really unlucky.
Okay, it's possible. That's one conclusion.
So, I'm not rolled with the dice or what you rolled with or something.
That's the only two conclusions. Either what you thought was going to happen didn't happen because this is an unfair die, unweighted, I'm rolling it on a hill or something, I'm doing something goofy with the experiment. That's one conclusion. That what I thought I knew is not true. Or, as Matthew said, you should have been here because you would have witnessed a really an amazing event, okay? There's no way you should get 4,000 ones out of rolling it 6,000 times. Now, it's not impossible, but it's very, very unlikely. That makes sense to everybody? And so that's what a lot of why we study probability. We know something about what we expect, and then we get something and we say, yep, what I thought is correct. Good to go. Fair dice, uniform distribution, because the data kind of confirms what I thought. Or, I say, what? No, wait a minute, that's not right. It shouldn't have happened that way, okay? And we spend a lot of the course doing this, okay? So let's go ahead and get started. I will pass out a worksheet. I think